So thanks for taking time from your lunch to come hear me talk. My name is Yarden. Today I'm going to talk about how our mindset needs to change when we code in Go versus in OOP languages in general, and more specifically in Java. So let me start by introducing myself. I'm a software engineer at Rookout. I really love learning new programming languages. I jump between them a lot, like in my day-to-day. I work with 6 programming languages, or maybe even 7. So that's something I really like. And this is kind of based off of that, right? And about how to jump between them. When I'm not coding, I also love to sew. So if you're also interested in that, we can talk about it. This talk is based off of my personal experience. When I started at Rookout about 2 years ago, my first task was translating our communication model from Java to Go. And I kind of just started by translating it like word for word. And that didn't work out so well. So these are the things that I learned. Now, the first thing that you need to know, is that the creators of Go had a really clear view of how they wanted developers to use their language. So they kind of created this unwritten set of rules that you have to follow when using Go. And they kind of force you to follow those rules in the language itself. So keep this in mind. It'll come up a lot as I explain how to design things in Go. And I did kind of want to take Go in the lens of OOP. So when I'm talking about OOP, I'm talking about these 3 principles, right? Encapsulation, just differentiating between what should be publicly accessible to all, or private, or only accessible to certain objects or classes. Polymorphism, which is using different types through the same interface. And abstraction, which is representing complexity through simple objects. Basically meaning that we don't need to know how something works in order to use it. Now, looking at these principles, these are the main concepts in Java which help implement them. First of all, we have classes, right? Everything in Java is a class. We have abstract classes and interfaces to help us with these principles. And we have access modifiers like private, protected, or public. In Java, there are so many concepts and features that help implement OOP, but these are the main ones that I want to focus on. When we look at Go, we see something a little different. First of all, not everything is a class or has to be part of one, so we can have just standalone functions, and we'll see a lot of them in Go code. We don't have classes, and instead we have structs, which are basically the same thing, since they can also have fields and methods. Go does not have private. It has more of protected, so anything you define will be visible in the scope of the package or the folder you're currently working in. But you can specify if something is protected or publicly accessible from other packages as well. And last but certainly not least, you have interfaces. And interfaces are very similar to Java interfaces because they just group a bunch of method signatures. And in order to implement an interface, you just need to implement those method signatures. Now, a very important difference in interfaces between Java and Go is that interfaces in Java look like this, right? We'll create an interface, we'll specify the functions or the methods in that interface, and then in the class that implements the interface, we're going to use the implements keyword, right? So take away these 2 words, right? Implements and car, and even though theoretically Toyota implements car, it will not by Java standards. However, in Go, you would write something like this. This is not Go syntax. Don't try to run this in Go. But you don't have to explicitly state that Toyota implements car. And this may seem like a minor change, but in fact, it really changes the way we design our code, because it means that we don't need to think ahead of time which interfaces we want and which interfaces we want to implement in our classes. We can just kind of implement our classes, and when we need an interface, we can write it there. Okay, and then obviously when we want to implement an interface, we don't have to go back and change any class or struct that already implements that. So stepping back to our 3 OOP principles, let's see how each of them is kind of reflected in the languages. So encapsulation, we've discussed private, protected, and public in Java, and in Go, just protected and public. And already here we can see kind of how we're forced to use the creator's unwritten rules or coding conventions. Because in Go, in order for something to be protected, it'll start with a lowercase letter, and for it to be public, it'll start with a capital letter. A lot of people really dislike that. I personally really like that. It adds a lot of structure to code, and I don't need to jump to a definition of something to know if it's public or protected. So it's kind of neat, but it also does really force you, like, you have no choice in the matter. Moving on to polymorphism, in Java you have inheritance of abstract classes and interfaces to implement polymorphism, but in Go you only have interfaces. And one of the main things about interfaces in Go is that the creators really recommend only creating interfaces when you need them. So usually what we do when we're kind of designing our code is saying, okay, we want to make sure that in the future, when we want to add more classes that implement this, we can do that easily. So we'll create an interface or an abstract class in Java ahead of time, right? But in Go, we won't do that. In Go, we'll say, if we'll need an interface, we'll create it. But for now, we'll only create the struct itself. And that means that we're not planning usually interfaces ahead of time, but only when the need comes up, we're going to create them. So this is important, because when we'll discuss abstraction, Java has abstract classes and interfaces, and Go, once again, only has interfaces. And you can use interfaces as a mean of abstraction, right? You can use interfaces to say, I don't want to specify the concrete type that I'm using. But Go does not recommend doing that. That's exactly what the creators don't want. They don't want to use interfaces as a means of abstraction. They only want to use interfaces as a mean of polymorphism. And because interfaces are so lightweight and so easy to implement, the result is going to be that interfaces are not a means of abstraction in Go. Now, this kind of creates a weird equation where Go doesn't have anything to implement abstraction, but if we actually look at the language and look at code in general, we'll find out that almost every single feature we have implements abstraction, right? Just creating a function or a variable or a struct in and of itself does create abstraction. So we don't need something specific in order to do that. Now, one of the main debates we meet is inheritance versus composition. And the Go creators had a very, very clear stance in this debate. For those of you who aren't really aware of this debate, inheritance is relevant for an is-a relationship. So for example, Toyota is a car, so we will use inheritance in that case. And composition is a has-a relationship. So for example, Toyota has a wheel, so a wheel will be a field. The way we implement inheritance in Java is by using extends, right? We'll just inherit something. Pretty self-explanatory. Whereas composition will just be creating a field. In Go, since we do not have inheritance, and they really, really only want you to use composition, then in order to implement inheritance, we're actually going to use composition. And so that might sound a little weird, and let me show you an example. So what we have here is a very, very simple diagram showing the two relationships, right? We have a dog is an animal, so we're going to use inheritance to implement that, and a dog has a tail, so we're going to use composition to implement that. Now, I'm sorry, but all the code is in Java. I think that way we can speak at the same level, because Go syntax does look a little weird. So these are my Java examples, right? We're going to have a dog. Composition, pretty simple. We have our tail field, and then we have inheritance, right? We'll extend animal. And the really nice thing about abstract classes, which just don't exist in Go, is that we can actually create a method, a concrete method, in that abstract class, right? I can create the move_to method and implement it in the abstract class, and now I can call move_to on the dog. And then that move_to method can call the take_step method, right? Now, unfortunately, that doesn't exist in Go, right? In Go, the creators said we only want composition. So how do we achieve the same thing in using only composition? Well, first of all, we're going to use an interface since Go does not have abstract classes. And the interface is going to be very, very simple, only the take step method. Maybe we should change it to, I don't know, stepper instead of animal interface, just for the naming convention. But for now, we'll keep it like that. And have that dog implement it. And now what we're going to have is just a completely separate function which accepts both the animal and the point to move to, and then uses a.takeStep. Now, this does seem like a minor change, but it is a big step when designing our code. Well, we're not inheriting behavior, right? We're not saying we'll take this and extend it, or we'll take animal and we'll override something in it, but we're saying we'll inject custom behavior, and depending on how we call the function or what parameters we pass to it, we're going to change the way the function works. So that is a big change in how we're thinking. And when you start using Go, you may have to do this manually, kind of just like think, oh, I need inheritance here, and then go, wait, how would I do this with composition, and translate it? But with time, you'll see that your code becomes better and is actually more adapted to these composition changes. Now, sorry. Okay. Since I do have a few more minutes, I did want to mention that there is a sort of inheritance in Go. You can embed struct in other structs. There's a reason it's called embedding and not inheritance. Don't use it as inheritance. When you embed a struct in another struct, you can access fields and methods of that struct. So in that sense, it is like inheritance. But it is only to be used for simplicity. So like if you have a dog that has a tail, and the tail can wag, and so you'd have to do dog.tail.wag, right? So you could use embedding structs to call dog.wag instead of dog.tail.wag. So that's for simplicity. Don't use it for inheritance, because when we start talking about overriding functions and stuff like that, things become complicated, they become buggy, and it's not really recommended. So it's used for simplicity and not for inheritance functionality. Now, if that sounds interesting, if I don't know, being forced to use certain conventions that you might not agree with sounds interesting to you, you should totally look more into Go. There's a ton of concepts to learn, from pointers to slices and arrays and packaging and Go routines and channels, and more recently generics too. So definitely dive into that. Thank you so much for your time.